Welcome back. Can you please check out the answers to the two problems that we tried? They certainly look a lot smaller now because both the sum and the difference did reduce. You have to include the values that can't be used because they make the denominator turn into a zero. And if the excluded values are not included in the answer, you will not get full credit. If you had no questions and everything came out great, then please move on to the next section, a very short bit about rational equations. If it didn't work out as well for you, then please stay around and we'll figure out how to do it. So I'm going to trade the answers now for a blank copy. Alrighty. So we're asked to add these two, and you know that we can't add fractions unless they have the same denominator. To make it easier to get that denominator, we are going to try factoring. So we could factor this numerator, take out a -1. I'm choosing not to. And I make a script n. I hope that won't bother anybody. Otherwise my n's turn out looking like h's. And this quadratic may factor. I'm hoping. So we need two numbers that multiply out to -10, add up to a +3, and that's probably going to be a 5 and a -2. So the denominator here will factor n plus 5 times the quantity n minus 2. And we're going to add that with 2 over n plus 5. But we're not going to add it yet because we have to take into account that there may be some values for n that make these fractions unreal. If the denominator turns out to be 0, then the fraction makes no sense. So we have to be sure to state our excluded values. Well, if n equals -5, this whole fraction is blown apart. Similarly, if n equals 2, and we've already taken care of the case here. This would have to be if n equals -5. So we're going to leave out when n equals -5 or when n equals 2. Leave those values out of our input domain. And now that we've factored, we should be able to just look at it and tell what the least common denominator is. It has to be something that n plus 5 times n minus 2 will divide into, and that n plus 5 will divide into. Well, I'm believing that's going to just be n plus 5 times the quantity n minus 2. This has to divide into that, and the n plus 5 will divide into that, so that will be a very good common denominator. Now the first fraction is already over that common denominator. We just need to get this one over. Well, it already has the n plus 5. It just needs the n minus 2. So if we multiply the denominator by n minus 2, we will have what we need in the denominator. But to keep it fair, we got to multiply the numerator also by n minus 2. So now we have -3n minus 1 over the n plus 5 times the n minus 2 plus, just going to distribute here, the 2 times the n, the 2 times the -2. Now some of you can skip these intermediate steps and go right to the answer in your head. That's fine. Since they're both over the same denominator, we can go ahead now and add them. Negative 3n plus 2n would be a negative n. A negative 1 plus a negative 4 would be a negative 5 over that common denominator. And the addition's done. But maybe, and we have this same case with regular old fractions, maybe we could reduce it. Maybe there's a common factor between the numerator and the denominator. And I'm thinking this negative n minus 5 looks suspiciously like this positive n plus 5. If we could just factor out a negative 1 in the numerator. Before we run out of room here. And now the n plus 5's cancel out. And our final answer is negative 1 over n minus 2, which is a lot simpler than what we started with. So the next one. We just have to be wary of the fact that there is subtraction in this. And we have to be more careful with subtraction than we do with addition. Maybe, I'm hoping, we can factor this denominator. We would need two numbers that multiply out to 20 and add up to 9. Well, that's looking like 4 and 5. So now that we have the denominators factored, we check, are there any x values in this case that we are not allowed to use because they make the denominator equal 0? Well, it's looking like we're going to have to leave out when x equals negative 5 again, and when x equals negative 4. Either way, we would get a 0 in the denominator, and the fraction wouldn't make sense. Okay, how about the least common denominator? Actually, this one's looking a lot like the one above, except that it's got x's instead of n's. It has to be something that this whole thing will divide into, and that x plus 5 will divide into. Well, that's just going to be this denominator right here. This one, fortunately for us, is already over that denominator, which I'm just going to bring down here. This one, though, only has an x plus 5. So this denominator is going to need a factor of x plus 4. If we do that to the denominator, we're going to have to do it to the numerator. It's only fair. So we end up with, I'm just going to multiply it out, 5x plus 20 over the x plus 4 times the quantity x plus 5. And we're ready to subtract. As long as we realize that we are subtracting all of this, not just the 2x, but also the 5. So we're going to end up with 5x plus 20 minus 2x minus 5. all over this one common denominator. And I am putting in all the tedious little steps. So they're combining the like terms. 5x subtract 2x, 20 subtract 5, and there we are. We have completed the subtraction. It's a lot simpler than it started, but it's not done. We can factor this numerator. Now sometimes it does us some good and sometimes it doesn't. Either way, we're going to try factoring. Because we have a common factor of 3. Oh, look. Now that they're both factored, we have an x plus 5 in the numerator, an x plus 5 in the denominator, and this is basically 1, x plus 5 over itself. And we end up with a final answer of 3 over x plus 4. As long as you don't try to put a -4 or a -5 in the original problem. So if you still have questions, please contact your teacher. Otherwise, we do have just a couple more items with solving an equation that involves rational expressions.